Hi everyone, Masudi here.
Hi guys, welcome back.
Last session, I remember we introduced some other HTTP clients like Retrofit that is widely used among Android developers, but it has nothing to do actually with the Android itself. As you can see, we are able to use it also here. And with Retrofit, as you remember, we just define the connections to the endpoints with just an interface function. And with the help of the annotations, and the Retrofit actually implements the body of these functions and gets back, creates an instance of the interface that just we asked. So in this session, first we are going to use another HTTP client named Volley, which is also developed by the Google itself, by the people inside Google. And then we will actually try to use our own HTTP client, this HTTP connector, against some other servers out there, not our own server, just to show that our HTTP connector works. So for using Volley, which is we have to add it as a dependency to the Gradle, and it will download its jar files. Oh, this one is AAR file.
So
as I guessed.
that's
We cannot use this
why?
because this is specifically designed for Android.
Oh,
This file is AAR, not jar file.
so this cancelled.
Yes. We cannot use Volley because the Volley is using the Android packages, and our project is not an Android project, and we've not added the Android SDK as the dependency to our Gradle, and it won't work actually. But Retrofit is a standalone framework. It is not dependent on any other frameworks at all, like Android. So we cannot use Volley, but I just wanted to show you that with other APIs written by someone else on top of socket and HTTP URL connection, they all do pretty much the same. For example, they receive a callback, but we couldn't use the Volley. So now, actually, I want to, as you remember, again, last session we tried to connect to some server, to this JSON bean server with our own HTTP connector, but we were unable to do that because it was HTTPS. And this session, I found this blog of Uncle Bob Martin, Robert C. Martin, if you know him. He's a famous guy in our industry. And this is the first page of his blog. Not the first, cleancoder.com/products. So as you can see, our browser has been connected to this endpoint and has get back an HTML page. And we want to try to connect to this page, to this server, not this page, this server actually, to the server which is running on, and it is not an HTTPS. We can connect with via HTTP protocol. So browser is connecting to cleancoder.com on port 80 and is asking for /products. And we just tried to do the same here. And let me just get rid of these for the moment and just give an empty map as the header. So our API that we developed ourselves, we have to create an HTTP request, give the host, the port, the method, request URI, headers, and the body. So because we know, let's inspect this website. Reload it again. Because we know that it is connecting via GET and it is sending these headers. The Chrome browser, when connects to this URL, it sends these request headers and it issues a GET HTTP request. So also we have to issue a GET on port 80 to this host. We can give the IP address, actually. It will convert it. The Java itself will convert to the IP. And the request URI is /products. And when we try to connect actually and get the body status and headers, let's see, it should connect, and it is not. Maybe it's because of the body. It's because of the body here. Oh, no, it's telling us unknown host exception. And unknown host exception. It is not able to resolve this name to the IP address. Let's try it again. Unknown host. Okay.
Oh, that works.
Okay, it works. And as you can see, it returns 400 as the status, and it returns this HTML as the body, which is telling 400 bad request. So if we go to the HTTP RFC protocol, the file, you can see that 400 means bad request. When server sends back 400, it could send other more information to tell specifically what is wrong, but we can guess that actually our request is not a, has something wrong. There's something wrong with our request. And as you can see, this browser is sending a lot of headers along with the request. For example, accept encoding, accept language, cookie, host, upgrade, user agent. All of them are defined in that RFC file, and some of them are sometimes compulsory. For example, some servers are very strict on these things. For example, they force the client to send the host or to send the user agent. User agent means in the user agent, the client sends the operating system and the HTTP client that is being used to connect to the server. For example, here we are using Chrome version 87, and we are connecting from Linux, for example, and other things here. And also the host means the destination that we are going to connect. So I guess that actually we have to also include these headers in our request. So we have to also send user agent, and I'm going to fake it. Actually, I'm going to introduce ourselves as Chrome. Let's copy and paste. And also, let's give the host to, we are going to connect to cleancoder.com. And now we try to connect again. And this time you see that we get back the response 200 with this body. This body is an HTML document that we are receiving. And if we copy this HTML and paste it into a file, I've done it before. Let me show you in the desktop. This is the one. And if we open it, you'll see pretty much this website here. But it has some CSS files that helps it to shape better, and it is not able to download the CSS. We have some CSS files here. You can see there are links inside the HTML. If we want to be also a browser, we have to extract these URLs and download them as well. But that'll do just for the moment. So you see that our HTTP connector, HTTP client, is acting as somehow standard HTTP client. Other servers out there are accepting requests from our own server, our own HTTP client, which is actually connecting directly via a socket on port 80. We are not using any third-party library, any framework here. We are not using even the HTTP URL connection class inside the JDK, which will do all of this for us. We are connecting through a socket and sending bytes and also receiving bytes and converting them to HTTP response. Okay, so this is enough. And now let's get back to our application. So I think this is enough for the moment about the HTTP server and HTTP client stuff, how they work. So we had this admin application, also customer application. Customer application is now trying to, let me run them. Actually, I forgot it. Okay, this is admin application, customer application as well. Ask for product list. Response was 200. I think we have a problem here. Actually, if you go to the HTTP RFC file, you'll see that in the header section, they state that the key of each header, because headers are key value pairs, the keys are not case sensitive. But here in the HTTP connector, we are actually asking for content length with capital uppercase C and uppercase L. And we should actually accept any content length, even like this, even if the server is responding like this. Because headers are case insensitive. The key of the headers are case insensitive. So this contains key should accept some ignore case, but we don't have it in the map, unfortunately. Let's see if we can use other functions in the map. Headers map dot first. No, we don't have the first. We have contains value, get or else. Let default any. We don't have first. We should have first. Okay, we can access the entries and ask for the first. Var it dot key dot to lowercase equals content dash length. We can use this one instead of this. Actually, I asked for the entries. I asked for the entries of the header maps, and the entries is a list of entries. And then upon that, I asked for the first with this criteria. I passed a lambda, then it passes all the entries to this lambda, and the first one, which is true, will be returned from this or an exception. So let me get it outside first. Or null, because we might not have a content length. Val content length equals if content length not null, then is content length content length let's see, let's bring it here, content length dot first or null. Then we have to do something like that. We have to get the key, not the entry itself. Trim dot to int. Let's run it again. Customer ask for, and okay. Oh, we should ask for the value, not the key. We should try to convert the value to integer, not the key. The key is content length, of course. Okay, we get back the apple and the orange. And as you remember, we tried to connect with Postman to our own server, and it worked. And also the browser itself, as a standard HTTP client, can connect to our server itself. 1, 2, 3, 4, 5. get product list, and also this works as well, and we can inspect that and see that in the network part, the browser is sending these things and it's receiving only this header, because our server, our HTTP server, is only sending back content length. We could send, we might send also other headers. Some clients, HTTP clients, maybe like Postman, might ask for other headers, like for example, content type, because we have a content length, meaning that we have a content. And in order for a Postman to understand what is the type of the content that we are sending back, we should also send back a content type. But we are not sending back, and the Chrome is relaxed with us with this request, and it only tries to print it here actually. But maybe other HTTP clients throw some exceptions or say bad response, for example. Okay, the admin is working, the customer is working, they are connected to each other via standard HTTP connection, and not some because before we had a protocol that we made it ourselves. I remember that, for example, we took backslash and not the backslash, and @ as the delimiter of the method, the request and the body. But now we are using HTTP. And from here on, we can implement other features and continue the project. So the customer can ask for product list, and also can place order. Let's check the place order, see what it does. Apple 10. No. Do you want to add to order? No. Actually, it seems that it's not working correctly. The place order. Let's see. It enter product amount. It creates a JSON. Do you want to add more? Read line if answer not equals to yes. It should break. It breaks and it tries to post. It should come here. Let me run it as debug to see what's going on there. Okay, 2 Apple 5, nope. Okay, we are here in the items. Then we are here. Then we try to send. But nothing is sent to the other side. And also, let's see why. Send request serialized body. Let's get rid of these. Host port. Maybe it is unable to connect. Customer application 120 place order on port 12345. Ask for product list is the same actually. Get 12345, get product list. It is doing the same. Two Apple 4, yes, orange 10, no. Okay, we are here and everything seems okay in the request. Then we get here. Then we connect. Get back the request URI, and we post. This is the request string. My most battery is gone. The request string is, let's see, this is the one, post / place order HTTP 1.1. Everything seems fine. Then the receive response here, we might have something wrong here, maybe with the content length. The content length, yes, it's not breaking, maybe here. And we don't see the exception. Why? Let's run it again. 2 10. Nope. Okay. Now we are here trying to read. And the read actually stops, hangs. The first read. Why? Maybe the server is not responding anything. Let's get back to the server. In the server we have this router here, and inside the place order we have order items, and the body order was placed. Let's see if it reaches here actually, because we don't see these print ln's in the admin side. In the admin side we don't see admin. Let's run it as debug, and also the client. Also run it as debug. Place order Apple 10. Nope. Okay, we are here. We are in the server. The request has been received. Then something goes wrong. But we don't see the exception. Oh, this is the exception. Host, but the JSON object test must begin with brace.
It has problem in the JSON.
Yes, it seems. But we didn't see this message before. So what is the message? Here, post, place order. Let's also print the body of the request in the admin. And issue the request again to Apple 10. Nope. Okay.
Again that?
The body is empty. The body is empty because of the server actually. And again, maybe because of this content length here.
Because of the small c.
Maybe. So again, we have to say, let's add, actually, I wanted to add a function to this, to the map, but let's just use the trick that we used before. So for content length, we did something like this. Content length equals headers dot. In the headers, the entries set. In the entries, the first one or null. The first one, which the key of the first one, which is equal to content length and the value of this. So this is the safe call operator, because first or null returns nullable value. Then we safe call the value on it, and it will be nullable string. Actually, it will be nullable string. Then here we can say if content length is not null, content length dot trim dot to int. Okay, let's run the admin again. Then the customer, place order Apple 10, nope, and yes, 201 order was placed and the admin receives the data. So the HTTP connector, if we see down here, or maybe here, yes, is including content length with uppercase C, with lowercase l, and in the server side, the admin application, in the server side, it actually tried to ask for content length with lowercase c. So it couldn't find the content length. But as we said before, the headers, the key of the headers are case insensitive, and we should take these into account. You know, we should search, when we are searching for content length, we should search it actually in the case insensitive mode. Okay, I think this is enough for this session. Actually, from the next session, we will continue adding features to the project. And now you can see that with the place order, anybody can place order from anywhere. And there is no authorization or authentication going on here. And as you can see with the retrofit, the JSON bean asked for this secret key, for example, to identify, to authenticate the user, actually to let us to create some content in the server. So all the servers actually has some kind of this mechanism for authentication, at least the authentication. So first the user should log in, and the very basic authentication is, they call it the basic authentication, in which the user includes its credentials, for example, the username and password, in each request that is sending to the server. But in more advanced authentication servers, they have other phases, like authorization after the user authenticates. So the user connects to the server, gives his or her username and password. The server authenticates the user and gets and responds with a token, like this. And we as client does not know what this token means, but we as client have to include this token with this key, because the server asks to send it with this key in the subsequent requests. So first we log in, get back a token, then we include this token in each request that we are sending back to the server. Then the server can recognize us, can, for example, know that, okay, this is this guy, which is trying to place an order. So actually now it's like someone anonymous is calling the shop with the phone and asking to place order, for example, for $10,000. First, we have to authenticate the guy on the other side. Actually, we have to ask his name, or maybe we know him or her by his voice. But there must be some kind of a mechanism for authentication or authorization as well. Okay, I think this is enough, and thank you. And next session we will continue.
Thank you, guys.
Bye.
Thank you. Bye-bye.